Dr. Robert Gehrz is a professor of physics and astronomy at the University of Minnesota, who has spent much of his life analyzing the stars for work and for pleasure. Recently, he agreed to join Avery and me in a Skype call to discuss his work and his advice for high schoolers who share a similar passion for outer space. We've put together a video of some of his most important points for another episode of Exeter Cosmos. Here it is.
I'm wondering how you feel about companies like SpaceX and Blue Origin and this sort of wave of private industry that's, or at least some people think, changing the game and busting some of these timelines for projects that have usually taken governmental agencies many, many years and sort of changing that, I guess, mindset about how we approach space. So I'm just
Well,
wondering how you feel.
they're basically doing rocketry,
Hmm. Okay.
advanced rocketry. They're delivering payloads. They're not actually developing a really sophisticated telescope like this. They're doing sophisticated things for sure. This telescope is probably the most sophisticated thing that's ever been launched into space. It has more than 200 moving parts that all have to operate in outer space at low temperatures. This is a very daunting technology, and we've got no way of getting out there and fixing this thing, unless maybe somebody like SpaceX can develop a thing that can do it. But you got to have robots that can work on it when you get out there.
Right.
So I think that the future of commercial space exploration has a lot of promising aspects, especially in terms of exploration for minerals. Maybe you want to talk about rare elements that can be mined from asteroids and things like that. Maybe delivering people into space eventually. Right now, we're not delivering people into space with SpaceX. I'm not sure that anybody's confident that they actually are error-proof enough yet. They've done some great stuff, but right now we're counting on the Russians to put our people into space. That's pretty sad. When you consider that we used to be supreme at doing things like that. We went to the moon.
Yeah.
Can't even deliver people into low Earth orbit
Yeah.
anymore. And the landings on the moon were not staged in a warehouse in Los Angeles. Yeah, so I think there's some promising aspects. Whether commercial ventures like mining for minerals in outer space is going to work will depend on supply and demand and what the ultimate costs are. But there are a lot of people interested in putting money into this, their own private money. I mean, we've got people who want to ride in space and they're willing to pay millions. They're rich enough to pay millions to do it.
I had a question just
Yeah.
for our young viewers for the Exeter Cosmos. I was just wondering, you've told us a lot about like what you've been doing for many years, and it's a very inspiring project. But I'm wondering sort of about your beginnings and how you originally got interested in outer space, and what about it particularly fascinates you.
So I went to a public high school. I went to a high school called St. Paul Central High School, a high school that boasts that it has more graduates who have become Rhodes Scholars than any high school in the country.
Wow.
And we had a ninth grade unit on science. One third of it was geology, one third was biology, and one third was astronomy. And I got hooked on the astronomy part, and in particular, I liked the physics associated with it. And in my particular instance, it was the images made at Bell Laboratories of solar prominences erupting that got my attention. And I realized in ninth grade I wanted to do astrophysics. So I came over here to the University of Minnesota as a ninth grade student and consulted with people about what I should be taking in order to become an astrophysicist. And they gave me advice and I took it. And so I worked on becoming an astrophysicist during my undergraduate career by just studying physics. So I got a Bachelor of Arts in Physics, and I took a lot of arts courses and learned to write. And then I spent 4 years getting a PhD in physics here at the University of Minnesota. And I did a PhD on low temperature physics, designing and building infrared detectors to put on telescopes to measure infrared radiation. So I did an astrophysical thesis. So to be an astrophysicist, you really become a physicist first. And what interested me about the whole thing was what we call basic research. My primary interest in space and exploration is not human exploration, it is exploration by remote observing and direct observing by visitation to extraterrestrial bodies and by observing them from a distance. So the projects that actually visit the planets also interest me. But it's the remote things that we can do that are where I get the kind of data that I use to interpret what's going on in the universe.
What would you say to someone who came to you with the argument that we shouldn't invest resources in outer space because we haven't solved some of the most pressing problems on Earth?
I think the creation of new knowledge is one of the most important pursuits that we have, and um, I believe that we need to be advancing on all fronts. We wouldn't be doing a lot of the things that solve some of the other problems on Earth without having done physics, and especially without having done astrophysics. We wouldn't know anything about gravity if we meaning humanity, hadn't been studying the motions of the planets. Imagine what we might know about gravity if we lived on a planet like Venus where you couldn't see other stars. We might know nothing about it. Now we can use it for all the communications that we do, for GPS, we know how to do orbits for exploration in space. We know about nuclear physics because of observations of stars. We wouldn't know anything about nuclear fusion, which could be the solution to the energy crisis, without having studied stars. We wouldn't even know about the element helium without having studied the spectrum of the sun. It's too inert to be reactive in the laboratory, except under special conditions. So by observing things in the astrophysical environment, we've learned a lot of stuff that is now practical on Earth. And think, by the way, about all the things that help with medicine and any manner of other problems on the Earth that have been developed through the space program. Next time you drink a glass of Tang, think about where that came from. It was developed for the astronauts. Velcro was developed for the space program.
So you've talked a lot about how a lot of your work focuses on exploration via um, via observation, right?
Yeah, remote observation.
Remote observation. That was the yes. So I'm wondering if you think there's a future for the human race outside of Earth.
Well, I certainly think we have the technology, given enough money, to explore at least the local vicinity, the solar system, in the next generation or two. We've been to the moon already. It's entirely plausible that we'll be able to explore Mars and some of the other nearby planets. Well, we're not going to go to Venus very comfortably at a temperature of 900 Kelvin or something, but we're gonna get to Mars someday. And there's even talk of terraforming Mars. You know about that?
Mm-hmm.
So these are interesting projects, but they're going to cost a lot of money. Now, the other interesting project that's technologically feasible is to protect the Earth from Earth-crossing objects that might create havoc, worldwide destruction. It's been shown technologically that we could fly some kind of a rocket out to one of these things, attach it to the surface, mine materials from the surface to create new fuel, and retard or accelerate the orbit of one of these things to make it miss the Earth.
Mhm.
If we happen to calculate that it was on a trajectory that would plunge it into the Earth at some point. So we're building a very large telescope that is sensitive enough to survey the sky for 10 to 100-meter size objects once a week that would cross the Earth in a couple of years. So we will have a couple of years warning once this telescope, it's called the Large Synoptic Survey Telescope, gets built.
Thanks for watching, and we'll see you in the next video.